Welcome back, everybody. Today, we're going deep on something.
Beep.
Yeah, a deep dive into something you might not think about too much, but
Yeah,
it really has huge implications for AI.
it does.
Good old OCR,
Yep.
optical character recognition.
Absolutely.
Remember
Yeah.
that?
Uh-huh.
You know,
Hmm.
it's funny.
Yeah.
Turns out it's playing like a starring role in
Yeah,
this super cool new AI tech called RAG,
that's right.
Retrieval Augmented Generation.
Retrieval Augmented Generation.
Yeah.
That's right. RAG is all about giving AI access to
Okay.
vast amounts of real-world information so it can answer your questions
Oh, wow.
accurately and with real-world context.
Okay.
Think of it like
Okay.
giving a super smart AI assistant
Yeah.
a library card to the biggest library imaginable.
So instead of just making things up
Right.
based on its training data,
Right.
it can pull in facts and figures from basically anywhere.
Exactly.
Really?
That's the goal, at least.
Oh.
But there's a catch. A lot of the world's knowledge is still trapped in PDFs.
Oh, yeah.
Textbooks, research papers, legal documents.
Oh, I see. Yeah.
You name it.
Yeah.
And to make that information useful for RAG,
Sure.
we need OCR to convert it
Okay.
into a format AI can actually understand.
Okay. So that makes sense. But converting a PDF to text doesn't seem like
Right.
rocket science.
Sure.
What makes OCR such a challenge?
Well, imagine you're an AI
Okay.
trying to read a faded handwritten recipe covered in coffee stains.
Oh, gosh.
That's kind of what AI is dealing with when it comes to OCR.
Yeah.
Different fonts, complex layouts,
Mm-hmm.
tables crammed with data,
Mm-hmm.
scientific equations.
Yeah.
It's not as easy as just snapping a picture
Yeah.
and getting perfect text.
So you're saying those little OCR hiccups we all encounter now and then,
Exactly.
a misspelled word or a wonky table could actually snowball
Yes.
into bigger problems for AI?
Exactly.
Trying to use that information.
Precisely. And that's where OHR Bench comes in. It's a benchmark designed specifically to test
Okay,
how well OCR performs when used for ARCHI systems.
I see.
They looked at 6 real-world domains:
Okay.
textbooks, law, finance, newspapers, manuals, and academic papers,
Wow,
to get a sense of how OCR performs across the board.
clever.
Yeah.
So what did they find?
Well,
Did any of the OCR systems pass with flying colors?
what surprised me the most is that none of the tested OCR solutions were perfect.
Oh, wow.
Even the leading systems
Really?
had a noticeable performance gap compared to
Gosh.
using perfectly extracted text.
So even small errors can have a ripple effect
Absolutely.
on how well RAG works.
Absolutely. And the impact depends on the type of error.
Okay.
OHR Bench breaks OCR errors down into 2 main types:
Okay.
semantic noise and formatting noise.
Okay. Break it down for us.
Sure.
What's the difference?
So semantic noise is all about the straight up errors:
Mm-hmm.
typos, wrong symbols, messed up data in tables.
Okay.
Imagine you're an AI trying to answer a question about a scientific study, but the OCR has garbled all the numbers in the results table.
Oh, no.
That's semantic noise,
Right.
and it can completely throw off the AI's understanding.
That sounds like a recipe for disaster,
Yeah.
especially if you're relying on that AI for, say,
Right.
medical diagnosis or
Exactly.
financial analysis.
Exactly.
Yeah.
And then there's formatting noise,
Okay.
which is more about the visual structure of the document.
Uh-huh.
Things like bold text, spacing in equations, or how tables are organized.
Right.
It might not change the actual meaning of the content,
Okay.
but it can confuse the AI trying to process it.
So like giving the AI a perfectly good book,
Right.
but all the pages are stuck together and out of order.
Yeah.
I can see how that would be frustrating.
It is.
Yeah.
Think of it like this.
Okay.
You might be able to understand a sentence with a few typos,
Uh-huh.
but if the words are all jumbled up,
Right.
it becomes much harder to decipher.
Yeah.
It's the same for AI.
So which type of noise causes more trouble for our RAG? The semantic errors or the formatting quirks?
The study found that semantic noise is the big bad wolf here.
Okay.
It consistently hurts both the AI's ability to find relevant information
Uh-huh.
and its ability to generate a good answer
Right.
based on what it finds.
Okay.
It's like trying to follow a recipe with the wrong ingredients.
Yeah,
You're just not going to get the desired outcome.
that makes sense. So what about formatting noise?
Yeah.
Does it cause as much chaos?
Formatting noise is a bit more subtle.
Okay.
It mainly trips up the AI on Complex stuff like tables and equations.
So even small formatting errors can have big consequences,
Exactly.
especially when dealing with complex data.
Exactly. The study found that even a single misplaced character in a financial report
Wow.
could lead a Reg system to miscalculate profits by as much as 10%, which could have huge implications for business decisions.
Yeah. Wow.
Huge.
That's crazy. Hashtag TTS, the deep dive episode 2024-1204, part 2 of 3. A 10% swing just from one tiny little character. That's crazy.
It is.
That's a stark reminder of how much we rely on accurate data, even if we don't always realize it.
It really highlights how those seemingly minor errors can have significant consequences, especially as we entrust AI with increasingly complex tasks.
Right.
And here's another wrinkle.
Okay.
The study found that while newer, more powerful AI models like GPT-4 are more resilient to formatting noise,
Okay.
they still struggle with those semantic errors.
So even the AI superstars aren't immune to bad data.
Exactly.
Garbage in, garbage out, right?
Garbage in, garbage out. And that brings up a fascinating question.
Oh.
What if we could bypass OCR altogether?
Bypass it.
What if AI could understand the information
Wow.
directly from the images,
Oh, okay.
skipping the whole text extraction process?
Now that would be a game changer.
It would.
But how would that even work?
Well, researchers have been exploring that possibility using something called vision language models, or VLMs. These models are designed to understand both images and text,
Okay.
potentially allowing them to extract information straight from a PDF image
Oh, wow.
without needing OCR to translate it into text first.
So are VLMs the OCR killing superheroes we've been waiting for? Can we just ditch OCR and let the VLMs take over?
It's not that simple, unfortunately.
Okay.
The study found that using only the image as input for the VLMs didn't quite match the performance of using OCR text.
Really?
Even when the OCR output had errors.
Oh.
It seems VLMs still have some catching up to do
I see.
when it comes to understanding complex documents on their own.
Okay, so no magic bullet just yet.
Right.
But I'm sensing a but coming.
You know me too well. Here's the really exciting part.
Okay.
When the researchers combined the image with the OCR text, even the error-prone OCR text, the performance jumped significantly.
Really?
In some cases, it even came close to rivaling
Wow.
the performance achieved using perfect manually extracted text.
Hold on. So the VLMs were actually able to use the image to compensate
Exactly.
for the OCR shortcomings.
Precisely.
That's incredible.
It is.
It's like the picture provided a context that helped the VLM decipher the messy OCR text.
Precisely, think of it like this.
Okay.
If you're trying to read a handwritten note that's full of scribbles and crossed out words, it might be really hard to understand on its own.
Right.
But if you could see the person writing the note, their facial expressions, the way they hesitated on certain words, you'd get clues that help you figure out what they meant. The image gives the VLM that extra layer of understanding.
That's a brilliant analogy. It makes so much sense now. So does this mean that VLMs could be the key to unlocking all that knowledge?
Potentially.
Trapped in PDFs and other documents?
It's still early days.
Okay.
But this research definitely points to some exciting possibilities.
Like what?
Perhaps VLMs could learn to correct OCR errors on the fly.
Wow.
Or even develop entirely new ways of extracting information from images.
Wow.
That are more accurate and robust than traditional OCR.
Okay, now my brain is buzzing with possibilities.
Mine too.
What if we could feed VLMs all the world's documents? Historical archives, scientific journals, even that dusty old cookbook your grandmother swears by.
Imagine the insights AI could uncover.
Right.
By connecting the dots between different fields, different time periods, different ways of thinking.
We could have AI generating personalized education plans. Analyzing historical trends to predict future events.
Exactly.
Or even designing groundbreaking new technologies.
Absolutely.
Based on principles discovered in ancient texts.
The potential is mind-boggling.
It really is.
And it all hinges on this fundamental challenge of information access, something we often take for granted.
Right.
But that has profound implications for the future of AI. Hashtag TTS, the Deep Dive episode 2024-1204, part 3 of 3.
Yeah, it really underscores how much potential is still untapped, just waiting for AI to have the tools to unlock it. I have to admit, this whole conversation has me thinking about OCR in a whole new light.
It's fascinating, isn't it?
It is.
We often think of OCR as this
Yeah.
mundane technology for digitizing documents.
Right.
But it's actually at the forefront of this incredible push to make the world's knowledge accessible to AI.
Yeah.
And perhaps even more exciting is the potential for technologies like VLMs to leapfrog traditional OCR and revolutionize how AI interacts with information.
So what stands out to you from all this research? What's the big takeaway that you hope listeners will walk away with?
For me, it's the realization that we're moving beyond simply recognizing characters and words on a page. We're on the cusp of a deeper understanding of information, a way for AI to grasp the meaning and context behind the symbols. It's like we're teaching AI not just to read, but to comprehend.
And what could that level of comprehension unlock for AI? It's almost too much to imagine.
It is. Once AI can truly comprehend information, it can start to reason, make connections, and generate new insights that we humans might never have thought of on our own. Think about it. Imagine AI combing through vast libraries of scientific research, instantly spotting patterns and connections that would take human researchers years to uncover.
Or sifting through historical archives, identifying subtle trends and correlations that could rewrite our understanding of the past. The possibilities are truly mind-boggling.
It all circles back to that question you posed earlier. What if all the knowledge in the world was instantly and accurately accessible to AI?
Right.
What doors would that open? What mysteries would we solve? What incredible advancements can we make?
That's a question worth pondering, listeners, as we wrap up this deep dive. I'm left with a sense of wonder and excitement for what the future holds. It seems like something as seemingly simple as OCR, or perhaps its successors, could play a pivotal role in unlocking a future where AI helps us understand our world and ourselves in ways we never thought possible. Until next time, keep those brains buzzing and never stop exploring the depths of information that surrounds us as a